Hi, Assalamualaikum. Today we're going to learn about the linear and quadratic equations. Right, first let's look at the linear equations. So we should know what is the meaning behind the linear equation. So when we say the equation is a linear equation, means that the power of x is actually 1. The highest power of x is actually 1, and it has the equation. That's why it is an equation, not a linear expression, right? So this is an equation, so we call this as a linear equation. Right, suppose we have x plus 1 equal to 3. So our aim is to find the value of x. So how to find the value of x? So before this we learned that we have to bring this 1 to the right side. So why we have to bring 1 to the right side and it becomes negative? Right, basically we have something like, alright, suppose we have x plus 1 equal to 3, but we want to make x alone, so meaning to say that we have to minus 1 here. When we minus 1 on the left side, so we have to make the equation balance, so we have to minus 1 on the right side. Now we have x plus 1 minus 1 will become 0, so this part will become 0. We are left with x only, so that's why we have 3 minus 1, which is equal to 2. So the story behind why when we bring 1 to the right side it become minus, because of this balancing of the equations. Right, now suppose we have x equal to x minus 2 equal to 5. So how to kind of solve this? All right, so we have x minus 2 equal to 5. So to make it x to just leave x alone on the left side, therefore we have to add 2 on the left side, and then we have to add 2 on the right side. So we are now having the x equal to 7. All right, so that's how we solve it. Right, now what about this one? All right, so suppose I want to make the coefficient of x is 1. Now the coefficient of x is actually 1 over 3. All right, so I just want to move this 3 to the right side, it will become multiply, right? But why is it multiply? Because we want to make the coefficient of x is 1, so we have to multiply 3 here. Well, we multiply 3 on the left side, therefore we have to multiply 3 on the right side. Now 3 with 3 can be cancelled, that's why we have x equal to 5 multiplied with 3, we get 15. All right, same goes to this one. All right, now the coefficient of x is actually 2. 2x is equal to 10, right? So we want to make the coefficient of x is actually equal to 1. So how do we make this? All right, so we have to divide with 2 on the left side. When we divide 2 on the left side, we have to divide 2 on the right side. So now this one will become x equal to 5. Okay, that's basically the linear equations. Right, so let's try to solve some linear equations. This is just a very basic equations that you have learned before, right? So I can just shoot this right here. I bring this, I multiply 2 all, so I'll have 3x minus 2. This is actually equal to 2x plus with 14. Now I want to bring those x with x, so I want to put x together and the number on the right side. Therefore I have 3x minus 2x. This one is equal to 14 plus with 2, and then I solve, I'll get add is equal to 16. Then I'm done with this one. Right, suppose we have the second equation here. What should we do? We should multiply, right? We should expand this one. We expand this and we expand this one inside here. Therefore we have something like 5 minus 5x. This one is equal to negative 6x minus 12, right? You can put x together, right? Suppose I want to bring this negative 6 to the left side and want to bring 5 to the right side. So what will happen? I'll have something like, right, so I bring negative 6x to the left side, it will become a positive. So 6x minus 5x, I have a negative 12 minus 5, because 5 is positive on the left side, therefore I'll bring to the right side, it will become a positive. Right, now 6x minus 5x will become x. This one will become a negative 17. Right, we are done with this one. Right, now let's go to example number 3. All right, quickly, when we see this fraction, we just multiply on the right side. We'll have something like 2x equal to 4x minus 1. What should we do? We should expand, so we'll have something like 4x minus 4, and then we bring those x together on the left side. All right, so I'll have something like 2x minus with 4x, so I'm left with the negative 4 on the right side, and then solving 2x minus 4x will give us negative 2x. This one is the negative 4. So to remove the negative 2, I divide negative 2 on the left side, I divide with negative 2 on the right side. So I'm done with this one, will become 1. So I have x is equal to negative 4 divided by negative 2, I'll have positive 2. Alright, so we are done with this one. So that's basically the linear equations. So let's now look at the quadratic equation. So what does it mean by the quadratic equation? So we should know when we have a quadratic equation, so the highest power of x should be 2. Alright, so we have this general form of the quadratic equation where we are given with the ax squared plus minus bx plus minus c equal to 0. That plus minus means that the value of b can be a negative or a positive value. Same goes to the value of c. Right? Now, suppose we have this quadratic equation. So we have to solve this quadratic equation. There are three methods of solving this quadratic equation. So the first one is by using the factorization method. The second one is by completing the square. And finally, we can use the formula. Right, so it depends on the situation or the question. If the question asks you to find the solution using the factorization, then you have to use the factors to find the solution of x. But if the question asks you to find it using the formula, then you can find it using the formula. Usually we try to solve using the factorization. Usually, I said usually, it's not necessarily. All right. So if we try to factorize this equation on the left side, therefore we'll have something like, let me use the blue color here. I have, of course, x plus 2, x plus 3 equal to 0. Right? Therefore, I'll have x plus 2 equal to 0 and x plus 3 equal to 0. And then I'll have x equal to a negative 2. Right? And this one will become x equal to a negative 3. So we have two roots here. Right, two answers for x. But what if you have to use the completing the square method? All right, completing square method, we have to take the, all right, we try to use this x. You consider this b value, so plus 5 over 2 square, and then you minus 5 over 2 square. All right, and then you have to add c. Right, you plus with 6, this one equal to 0. And then you will have something like, all right, so now I have x plus 5 over 2 square. This one will become 25 over 4. I bring to the right side, minus 6. So when we have 25 over 4 minus 6, we'll have something like 1 over 4. Right, so we have x plus 5 over 2 square. This is actually given by 1 over 4. Right now, I want to remove the squares. I have x plus 5 over 2. This one will become plus minus square root of 1 over 4. So the square root of 1 over 4 is actually plus minus. So this is actually given by plus minus 1 over 2, because square root of 1 over 4 is equivalent to 1 over 2. So now we try to solve this. All right, so we have, okay, kind of two answers here. Let me use the green color. Right, so firstly you consider the positive part, right, this one with this one. All right, now you have x. All right, so I'll write it here. So I have x plus 5 over 2. All right, x plus 5 over 2 equal to positive 1 over 2. Another one, we have x plus 5 over 2. I have a negative 1 over 2. When we try to simplify this one, right, we'll have the two answers here. Right, we should get the same answers. All right, now that's how you completing the square. You can just use this formula actually. Another one is by using the formula. So when you want to use the formula for the quadratic equation, you have to consider the coefficient of x squared, coefficient of x, and the constant. In this case, the coefficient of x squared is actually, all right, in this case a is actually 1. The coefficient of x is actually 5, so b is equal to 5, and the coefficient of c is actually given by 6. Therefore, you just plug in inside this formula. You have something like x and negative 5 plus minus square root of, right, b square is actually 25 minus 4 multiplied with 1 multiplied with 6 divided by 2a. 2a is actually 1. Right, so I'll have something like, you simplify this, all right, you get a negative 5 plus minus with the square root of 25 minus 25 minus 4 multiplied by 6, you get 1. So that one is actually square root 1 over 2. So you have one, all right, two answers here. negative 5 plus 1 over 2, comma, negative 5 minus 1 over 2. Therefore, you will have same answers here. You get one answer is actually a negative 2, another one will be a negative 3, right? You have two answers. You try to solve until you have the value of x. So that's basically three methods of solving the quadratic equations. So let's try to see some examples here. Right? Suppose we have these quadratic equations with the variable x. All right, now we have this. All right, can we factorize this? If yes, then try to use the factorization method, right? That's the easiest one. So we have something like, all right, now I have m as the variable, so be careful, it's not x. All right, so I have something like, this one will be, I guess, negative 7m plus 1, right? Yes, because negative 7m plus with m will become negative 6m, yes. So I have m minus 7, this one equal to 0, another one m plus 1 will become equal to 0. So I have m equal to 7 and another one m is equal to a negative 1. So this is what we call the answers or the roots. You can in fact use the what we call the completing the square method. Suppose I want to use the completing the square method, right? So if the completing the square, you have to use the formula, right? You have just b over 2 which is 6 over 2, so you have 3 squared minus 3 divided by 2, sorry, 6 divided by 2, you get 3 squared, you have minus 7 is 1 is equal to 0, and then you have m minus 3 squared, right? This one will become a negative 9, will become positive 9 on the right side. I bring this, all right, I bring this all to the right side, so I have plus 7. So this is actually m minus 3 squared given by 16. Therefore, I just want to remove the what we call the square here, so I just to take plus minus square root of 16. The square root of 16 is actually 4. Therefore, I have one equation is positive 4, another one equation is actually a negative 4. Therefore, I have m which is given by 4 plus 3 which is 7. Another one m is equal to negative 4 plus with 3, we get a negative 1. All right, so same answers. All right, so you have two solutions here. You can try this using the formula. All right, let's see the second one. Suppose we have this type of equations. So this is very easy because you know when you have this actually x squared minus 121 is actually 11 squared. All right, recall the factorization for this type of, you know, a squared minus b squared, and then you will have a plus with b, a minus with b. In this case, you have x plus with 11, x minus with 11. This is equal to 0, so you have x plus 11 is 1 equal to 0, or x minus 11 is 1 equal to 0. It's or, not and, right? So x is equal to negative 11, and then you have another one which is x equal to a positive 11. All right, so you have two answers here. All right, now let's go to example number 6. Suppose we have example number 6 here. So what should you do? All right, you try to factorize this actually, because you have x squared here and x here, so you can factorize x. So you have something like x plus with 6, right? This one equal to 0. So of course you can consider x equal to 0, another one x plus 6 equal to 0. So you have x is equal to 0, another one x plus 6 equal to 0. Therefore our answers will be x equal to 0, another one will be x equal to a negative 6. We are done, right? So let's try this one, right? What if we have this you know, quadratic? You cannot factorize this one, I guess. All right, so what you should do is by using the what do we call the formula, right? So you can try to use the formula, which is a negative b. All right, I'll rewrite the formula: plus minus square root of b squared minus 4ac, you divide with 2a. All right, now you have to identify the value of a is actually 1, b is actually positive 10, and c is actually a negative 10. Sorry, a negative 3. Right? So a is actually 1. So you just plug in inside this formula. You have something like a negative 10 plus minus square root of what we call b squared is actually 10 squared minus 4a is actually 1, c is actually a negative 3. Therefore, this one is under square root divided by 2a to multiply with 1. And then you try to simplify this. Right? Negative 10 plus minus that one will be 100 plus with, all right, 100 plus with 12. You get 100 plus 12, 112, all right? This one divided by 2 two answers here, therefore you get x. The first one may be a negative 10 plus with square root 112 divided by 2. Another one will be x, which is negative 10 minus square root of 112 divided by 2. Right, you can use the calculator to find these solutions. So negative 10 plus with square root 112, and then you divide with 2, you'll get, suppose you take this, because the answer is in decimal, so you can just use the 4 significant figures here, so 0.2915. Another answer will be the, what we call, negative 10, you minus square root of 112, all right, and then you divide with 2, you get a negative 10.2915, right, something like this. You get four decimal places here, right, negative 10.2915, all right. So you are done with this one, all right. So in this case, you have no choice. You cannot factorize this quadratic equation. You have to use the formula in this case, right? Okay. Right, so now let's look at the concept of the discriminants for the quadratic equation. What is a discriminant? Actually, the discriminant is the part where we have b squared minus 4ac, which is the one under the square root inside the formula for the quadratic equations. Right now, we have to consider three cases here. The first one, when we have the discriminant value, which is b squared minus 4ac, which is greater than 0. When we try to substitute with the value of b, a, and c, and then we have it greater than 0 for b squared minus 4ac, therefore we have something like this. The graph will look like this, meaning to say that we have two roots here, all right? So we have root 1, and here is the second root, meaning to say that when you use factorization or you use the formula, you get two different answers. So we call this as two different roots, all right? Two different roots, or sometimes called two distinct, all right? Two distinct roots, all right? So sometimes we call this as distinct because they are unique. Distinct, all right? Distinct. Okay, all right. Two two unique roots, all right. But if you have a b square, all right, you have b square minus 4ac, which is equal to 0, and then you have only one root here, all right. So we call this only, we say that we only have one root, right? One root. Okay, I guess a unique root, all right? A unique root, one root, all right? Or sometimes we have two roots, but they are the same value. So that's meaning of b squared minus 4ac, which is equal to 0. But if the graph is hanging like this, so we'll have a complex root. Before this, we'll say that, okay, this is no root, but we actually have the root because we have learned the complex number, so we have the complex roots. Right, let's look at three different cases here. Right, so this one is for b squared minus 4ac, which is less than 0. Okay, suppose we have to solve this equation. So try to factorize 2 because we can divide everything with 2. When we divide everything with 2, we'll have something like x squared minus 4 x minus 5, which is equal to 0. Right? Now I want to factorize this. Can I factorize this? All right. Yes, you can factorize by multiplying what we call this one will be a minus 5. This one is plus 1. Equal to 0, yes, negative 5x plus with x, or negative 4x, all right. So we'll have something like x minus 5 equal to 0, x plus 1 equal to 0, so you have x which is equal to 5, another one x equal to negative 1. We have two different roots, so can we check the discriminants now? Yes, right, let's just consider this part. Or if you want to consider the initial equation, also okay. Right, so we want to check b squared minus 4ac. Is it greater than 0 or equal to 0 or less than 0? So if we take a negative 4 square, you minus with the, what do we call? 4a is 1 and c is actually a negative 5. And this one will become 16. Alright, so this is actually 16 plus with 20, right? Plus with 20, and this one will be 36. So 36, which is greater than 0. That's why we have two different roots here. Let's try to see this one. All right, can we guess? Yes, of course, by finding the b squared minus 4ac. Right, so b is actually a positive 4, so 4 squared minus 4, a is 1 and c is 4. Therefore, we will have, right, 16 minus 16, so this is actually 0. So when b squared minus 4ac, which is equal to 0, meaning to say that we have only one root. When we have one root only, so we try to solve this one by factorization. All right, so we have something like x plus with 2 square equal to 0. Yes, therefore we have x plus 2, which is equal to 0. Another one, x plus 2 equal to 0. So x equal to a negative 2 and x equal to a negative 2. So we can say that this only have one root, or it have two equal roots, right? All right, let's now look at this example 10 here. So we have to check whether this quadratic equation will have what type of roots does it have. So we have to check the discriminant. So let's just check the b squared minus 4ac. Right, so this is given by b is actually a negative 4, so negative 4 squared minus 4a is actually 1 and c is actually 5. Therefore, we have something like a negative, this one is actually 10 minus with 20, right? 16 minus with 20 will have a negative 4. So b squared minus 4ac is actually less than 0. So we know that this will have a complex root. So do you still remember how to use the quadratic equations with the complex roots? So let's try this one. We have to use the formula. So negative b plus minus square root of b squared minus 4ac divided by 2a. Now I put in the values for negative b, which is negative of negative 4, we'll get a positive 4, plus minus with this b squared minus 4ac is actually a negative 4, so I put in here negative 4, divide with 2a, 2 multiply with 1. So I'll have, alright, the case where I have a plus minus square root of 4, square root of negative 1. I break the square root of negative 4 into two parts here, right, because I want to write the square root of negative 1 as the I, which is the complex, right? So I divide it by 2, multiply with 1, we get 2. Now I continue here. I have one case where x is equal to 4 plus with square root of 4 is actually 2, square root of negative 1 will be I. You divide with 2. Another one, you will have x equal to 4, you minus square root of 4 is actually 2, and square root of negative 1 will become I, will be divided by 2. We solve this one, you simplify, you get 2 plus with I. Another one will have 2 minus with I. So you have the complex roots, where in the case you have b squared minus 4ac, which is less than 0. So this is the answers. Right, so that's basically the quadratic equations. So thank you for watching this video.